one of the things that I could see from a mile away is usually interface pollution. And it's, again, a cause of people trying to design with interfaces instead of discovering them. Right? I want that concrete implementation first, and then I want to apply the idea of what can be decoupled, that precision around decoupling. And I want to give you an example of interface pollution, things that I've seen before in code reviews. And this one is a kind of just a nice base, so you can get an idea again of when you're polluting with interfaces, not only are you taking that allocation cost, right, but you're also making the code harder to read, harder to maintain, and you're not gaining any value for it. That's what we're trying to do as developers, right, during those readability reviews. We're trying to figure out, hey, where are the smells here? Do we understand those smells? And how are we going to minimize, the code that we're writing and keep those mental models in place? So let's take a look at some interface pollution here. Now, this actually comes from a code review that I did several years ago. I had a friend of mine ask me to do a code review, and he was building a package to help people write TCP servers. And he wanted me to look at some specific aspect of the code. And when I opened it up, this is what I saw. I saw an interface right there, like you see on line 9, that was named server with these 3 well-defined behaviors: start, stop, and wait. And immediately when I saw that, the code review stopped. And it wasn't even the aspect of the code that he was asking me to look at, but I couldn't get past it. Now, what are the smells? Why am I stopping this code review right here? Well, there's several things that just start blaringly obvious to me that we're going to have a problem here. One is that the name of this interface is server, right? It's a noun, really. It's describing this thing. And if we talked about our concrete data, which is what's real, needs to describe the persons and places and things, what's real. Remember, interfaces are supposed to be describing behaviors. And this isn't even within the scope of its name describing a behavior. So that's an immediate smell. The other smell here is that it's a 3-method interface. Now, that's not necessarily wrong, but again, these are discrete behaviors that could be composed together later on to form these behaviors when they're needed, right? I can't imagine that every aspect of the code I'm about to look at always needs all 3 behaviors. So there's smells there as well. And remember, the developers telling me that they're implementing a package to support the ability to write servers. And already I'm thinking, do you have 2 implementations of this support? Because remember, we don't need an interface unless we need to decouple something. And decoupling means that we're going to have more than one implementation of something, right? Polymorphism means that a piece of code changes behavior depending upon the concrete data it is operating on. But if it's only operating on one piece of concrete data, then we don't need that decoupling. We can work with what is and not worry about what does. And so one of the very first questions I asked the developer was, do you have multiple implementations of a server, or are you asking the developer who's using your package to write this behavior? And in both cases, the answer was no. No, I'm not asking the developer to implement this. I did. And no, I only have one implementation. So all of these are those signs where this developer was designing with the interface and not focusing on their concrete implementation first. And all of that we got out of basically 4 lines of code there. But even if you start to scroll through this code, you see that the concrete type server, which is the true implementation for what it was he was building, was starting off in an unexported type, right? Server unexported, with a factory function that's returning not the concrete value, but the interface value. And really, that's a smell. The whole idea of a concrete function is to construct the concrete data, initialize it for use, and send it back up that call stack, right? Whether it's our value or pointer semantics. This developer's sending back the interface. And again, there's going to be almost little to no value here. Or there are some exceptions to these rules. The network package with the con is a fantastic example of a type that kind of is on the edge of all of these guidelines. But for the most part, these guidelines, when you see them, they're pretty good to hold true with. And you can see the rest of the API, again, leveraging the unexported type. And for me, the clincher really is right here in main, because now as a user of this package, do I really care on line 54 whether SRV is an interface or a concrete type? Does my world change at all, whether it's an interface or a concrete type? In fact, I would say my world doesn't change, but even more important than that, you know, the fact that I'm getting an interface didn't make my life any better. It just added the decoupling, right? That level of indirection and allocation. So I'm taking costs here for zero gain, basically, zero gain. So it took me about 20 minutes to convince my friend that we've got problems here. We've got to fix this. Like, we're not going to use an interface for the sake of using interfaces. You have one implementation of this. Let's use that concrete type. And essentially, after about 20 minutes, I got my friend to the point where we were able to remove the interface itself. We made that concrete type the exported type. We did that implementation. We return the address of the now exported type, but the concrete data really is what I want to say here, not the interface, but the concrete data. And we can come back into main and see that this code looks identical. And now that we're working with the concrete data, it gives that developer the ability to just do a little bit more and to get rid of those allocations if that's something that ends up being important. So these are some guidelines that we're moving forward with, things that I've just touched upon. But let's just kind of sum up everything that we just kind of talked about around interface pollution. And these are the guidelines that I want us to use when we're going to use an interface. We need that interface when users of our API need to provide us an implementation detail that we can't do ourselves. We're not going to necessarily know all those implementations, right? That's that core idea around that polymorphism. If we're going to have multiple implementations of something, then we need that indirection, right? That indirection, the decoupling, gives us the ability to have multiple implementations. So either we need some implementation detail from that caller, from that user, we're going to have multiple implementations of something, or there are just very clear and obvious places in that code that need to be decoupled, right? Again, around that idea of polymorphism. But anytime you're going to see the use of an interface and it's not obvious and clear why it's there, I want you to question it. If that developer is saying that that interface only exists so we can write tests, that's really bad, right? From my perspective, we're writing code for users. We're writing code to build apps, not to build tests. So if you're having struggles writing tests, we're not going to make changes to the API to make it testable, right? We want to make sure that that code is always usable first. We may make changes to make the code testable, but for me, it's not going ahead and starting to add interfaces and new types to make that happen. It's more about how do we break down these functions that are not testable into functions that can take concrete data in and concrete data out. You know, reorganize some things, not make APIs a little bit more generalized. That to me is a smell. All right, so we're looking to make sure that that interface is there and that it's obvious that it's providing support. If it's not obvious, if it doesn't, you know, if it's not providing that decoupling support, probably polluting that code. If it's not clear how the interface is making the code better, it probably isn't as well.